Okay, next up is part 2. Now we're going to answer questions 4, 5, and 6 on the graphing practice worksheet. If you're trying to figure out how to do the ones before that, it's a different video. Now we have a velocity versus time graph. Again, the whole point of this worksheet is for you to understand that the slope of a position versus time graph is velocity, and the slope of a velocity versus time graph is acceleration. So the first question I had asked was, what is a velocity? And really, you were just figuring out the slope. Here, I'm going to ask, what is the acceleration? And again, you're really just calculating the slope. The second thing you need to know is that the area underneath the graph of a velocity versus time graph is displacement. So if I'm asking for displacement, again, I'm really just having you calculate area. Okay, first up, so we need to figure out acceleration. So we're going to figure out the slope. So my slope is going to be, again, as always, rise over run. All right, some people are trying to get points in the middle. I don't know why. Just take the two endpoints. It's going to be the easiest to calculate. I have my first point is there, my other point's there. So my rise is going to be starting at 60, going down to 0. All right, so I have my rise will be 0 minus 60. It's going down, so it should be a negative number. My run is starting at 0, ending at 70. So I'll have 70 minus 0. All right, so we're going to plug that into a calculator, and I get that my slope is 0.857. So again, I calculated slope, but slope is acceleration here. So this slope of 0.857 is also my acceleration, 0.857 meters per second squared. Now to figure out the displacement. Again, the displacement is your area under a velocity versus time graph. All right, you have a triangle. So we know that the area for a triangle is just 1/2 base times height. Our base, again, is the same as our run. So our base is going to be from 0 to 70. So we have 1/2. Base is going to be, try again, 70. And our height was our rise. And it doesn't matter that it's negative, so our rise is 60. You multiply that out, it's easiest just to put 0.5 as half times 70 times 60, and our area is going to be 2100. All right, last thing is about the equation for final velocity. So what I'm really looking for is the VF equals VI plus AT. There it is. And so our velocity, we're just going to say VF is equal to our VI, initial velocity is 60. Our acceleration was our slope, which was negative 0.857. Sorry, I forgot to mention that should be negative up there. All right, and I'll just say times t, and that means we have an equation for a line, so anywhere along this line we could figure out what the velocity is. And there you go, that's the end of part 2.